Hello everyone. In this video we're going to be talking about geometric sequences. So we've already talked about arithmetic sequences, which is a sequence where you add or subtract the same number to get to the next term. And then for a geometric sequence, it's going to be similar, but in a geometric sequence the ratio between consecutive terms is the same. And so this ratio is called the common ratio. So last time we had common difference. Now we have common ratio. And here each term is found by multiplying the previous term by the common ratio. And ratio means fraction, so it's really saying that when you divide that second term by the first term, that's going to be your common ratio. So let's look at this example. An example of a geometric sequence would be 1, 5, 25, and 125. And that's because I am multiplying by 5 each time. And if you don't see that right away, you could also take the first term and divide it with the second. So for instance here, I take the second and I divide it with the first and I get 5. I can do that with all of these. So 25 divided by 5, I get 5. 125 divided by 25, I also get 5. And so with geometric sequences, our common ratio is always what we're multiplying by each time. And so if we have something where we're dividing, we're going to represent that as a fraction, just like what we did when we were talking with exponential functions. So for example, if I had this sequence but just flipped, I see them dividing by 5 each time, but I would really write that as multiplying by 1/5. And so to find that fraction, you're going to take that second term, the 25, and divide it by the first term, 125. And then you're going to simplify that fraction, and that would simplify to be 1/5. So let's look at some examples when we're identifying sequences. So with these sequences, we're going to determine if it's arithmetic, geometric, or neither, and then we're going to explain. Okay, so here I have 3, -15, 45, -135. When I see it go from a small number to a large number, that clues me in that I'm multiplying by something each time. And so I see to get from 3 to -5, I need to multiply by -5. But now I need to check whether the same is the case for the rest of these. And so if I do -15 times 75, or -15 times -5, I get 75, so that's good. And then 75 times -5, I get -375. And so I see I'm multiplying by the same number each time, so that means that this one is geometric. My reasoning would be common ratio is -5. Okay, let's look at the next one. So here I have 2, 6, 10, 14. So to get from 2 to 6, I multiply by 3, but then 6 times 3 is 18, not 10. So I'm not multiplying each time. So let's see if I'm adding the same thing each time. So to get from 2 to 6, I add 4. 6 to 10, I add 4. And then 10 to 14, I add 4. And so I am adding the same number each time, so that means that this one is arithmetic. And my reasoning would be common difference is 4. Let's look at this next one. So I have 140, 70, 35, 17.5. So I noticed going from a big number all of a sudden to really small. So that clues me in that I'm dividing or multiplying by a fraction each time. And so to find what that fraction is, I'm going to take the second term and divide it by the first term. So I have 70 over 140. And when I simplify that, I get 1/2. Okay, now if I multiply 70 by 1/2, let's do that work over here. Multiply that by 1/2, I get 70 over 2, which is 35, so that's good. And then if you multiply 1/2 and 35, you get 17.5. So I am multiplying by 1/2 every time, so that means that this one is geometric. And I can say that the common ratio r is equal to 1/2. Now looking at this last one, I first checked to see if I'm multiplying the same number each time. So 2 times 3, I get 6. 6 times 3, I get 18, which isn't 11, so it's not geometric. Here I'm adding 4, then I add 5, and then I add 6. So I don't have a common difference, so it's not arithmetic. So that means that this one is neither.